Hello and welcome back to another video. Here we are going to solve the last two questions from Specimen paper of 2020 from 9700903, that is Pure Mathematics 3, and it is paper 3. So here is the question number 9. The diagram shows the curve y equals sine square 2x into cos x for x between 0 and pi by 2 and its maximum point m. Here it is m and it is maximum. First part is to find the x coordinate of m. So since at m it is maximum, so at m dy over dx would be 0. So that would be very helpful for that. So we are going to find the derivative of this, and it is going to be, since it is a product of two function, sine square 2x into cos x, so we'll use the product rule to find the derivative of it. So first I'll write sine square 2x as it is, and derivative of cos x is minus sine x, so minus will come in front and it become sine x, and plus cos x this times as it is, and multiplied by the differentiation of this, and since it is sine square 2x, so first of all we'll use the chain rule, and that is going to be 2 times sine 2x, and derivative of sine 2x is cos 2x, and again derivative of 2x is 2. We are using the chain rule. So it is given that at m dy over dx would be 0, its derivative would be 0 because it's maximum point. So we can write it as, I'm taking this to the other side and writing this here, so it becomes 4 times cos x cos 2x sine 2x equals sine x and sine square 2x. Be careful with that because we have put it equals 0 and then this I transfer it here, so it is like that without negative sign. And now we can see sine 2x, 1 sine 2x we can cancel because we are not at m, this is never going to be 0. Here we are going to convert them into one trigonometric ratio anyhow. So what I can see that we can convert this cos 2x also and sine 2x also. So let's convert this one by one. So 4 times cos x and cos 2x we can write 2 times cos square x minus 1 equals sine x multiplied by sine 2x, double angle of sine is 2 times sine x into cos x. So we can see this cos x also got cancelled, so we are left with 2 cos square x minus 1 times 4 here, and here it is 2 sine square x. So we will convert this to sine square x and we'll get 8 cos square x minus 4 equals, it is 2 times sine square x, which we can convert it and write as 1 minus cos square x. So let's simplify it. Now we have everything in cos square x, so it would be easier to solve. So let's expand it. It is going to be 8 cos square x, and this 2 cos square x this side it becomes plus 2 cos square x, and here it is already 2 times 1, that is 2, and minus 4 this side would be plus 4, that is going to be 6. So we got it as 10 cos square x as 6, or cos x as plus minus root 6 by 10. Root 6 by 10 we can write 3 by 5 as well, but that's fine. Now we can see between 0 and pi by 2, and here we know that between 0 and pi by 2 cos is never going to be negative, so we can remove this minus sign, we can only take the positive one, and from there we can get x value as cos inverse of only root 3 by 5, and we will calculate from the calculator this value, and this value is 0.6 6847. 6847, so till three significant figure it is 0.685. I hope it is clear. Let's do the next question. And be careful, we could have written cos 2x as 1 minus 2 sine square x. In that case also we were getting the same, we are going to get the same result here, but that's fine if you have started with the cos square x. And moreover, between 0 and pi by 2, cos is never going to be negative. That's why I have excluded this possibility. Otherwise also we could have calculated this, and in that case you will get cos inverse of minus root 3 by 2, and that is going to be 2.456, and that would be more than pi by 2. That's why we have excluded this. So for that, x coordinate of m is 0.685. Here's the B part. Using the substitution u equals sine x, find the area of shaded region bounded by the curve and the x-axis. So I'll bring the function curve as well as the diagram of it. Now from here we can see y equals sine square 2x. If we'll substitute u equals sine x, so we are going to substitute everything. Here this is 0, so limit will also be changed, and the area, we know area is if it is in x, so it is x from 0, required area, x from 0 to pi by 2, it is 0 to pi by 2, y dx. This is the area, and if we substitute, we are going to substitute every value, and since u equals sine x, so we need to convert dx also. So for that we'll differentiate it. We'll get du over dx as cos x. From here du is cos x dx. So we got one value to replace cos x. Wherever we'll get cos x dx, we can substitute by du. And when x is 0, it is going to be sine 0, which is 0. And when x is pi by 2, u is going to be sine pi by 2, that is 1. So this area we can represent as 0 to 1, and y I'm going to write it once. It is going to be sine square 2x, so we can write it as 2 times sine x cos x whole square and cos x dx. So we are going to substitute this cos x dx as du. So we got it as 0 to 1, 4 times sine square x, that is u square, into cos square x and du. We still have to remove cos square x, and we know that cos square x is 1 minus sine square x. So it would be 0 to 1, 4 times u square into 1 minus sine square x means 1 minus u square and du. So it's simple integration now. We are going to separate it. 4 times 0 to 1 u square minus 4 times 0 to 1, and with respect to du, 0 to 1 u power 4, because u square into u square is u power 4, and du. So this value is going to be 4 times u cube over 3, 0 to 1, minus 4 times u power 5 over 5, the integration, 0 to 1, and which is 4 times 1 over 3 minus 4 times 1 over 5, because lower limit is 0, so it would be ultimately 0. So we got it as 4, 1 over 3 minus 1 over 5, it is 15, 5 minus 3, 2, so it become 4 into 2 over 15, that is 8 over 15 square unit. That is the area. I hope it is clear. Let's do the next part of this question. Here's the question number 10. In a chemical reaction, a compound X is formed from two compounds Y and Z. The masses in grams of X, Y, Z present at time t seconds after the start of the reaction are X, 10 minus X and 20 minus X respectively. At any time the rate of formation of X is proportional to the product of masses of Y and Z present at the time. When t equals 0 and x equals 0 and dx over dt equals 2. So first part is to show that x and t satisfy the differential equation dx over dt is 0.01 times 10 minus x times 20 minus x. So we know it is given when x for x, y, z at any time t, this x is x, y is 10 minus x and z is 20 minus x. So this condition is at any time the rate of formation of x means dx over dt is proportional to, means it is proportionality sign to the product of masses of y and z, and mass of y is 10 minus x, mass of z is 20 minus x, so its product is this. And if we'll remove this proportionality sign, we can use the proportionality constant, and hence dx over dt is k times 10 minus x 20 minus x. But it is given that when x equals 0, dx over dt is 2. So when x equals 0, at t times t 0, x is 0 and dx over dt is 0. So we are going to substitute dx over dt become 2, k times 10 minus 0 10, 20 minus 0 20. So we got it as k equals 1 over 100, that is 0.01, and hence dx over dt can be written as 0.01 times 10 minus x and 20 minus x. We only need to get the constant. This constant we got, we substitute it here and we got the dx over dt. So let's do the b part of this. Solve this differential equation and obtain an expression for x in terms of t. So first of all we'll need to solve the differential equation and then we'll obtain an expression for x in t, x in terms of t. So I have copied the differential equation from the first part. Now we are going to solve it, and we can see there is a product of linear factors. So if we'll do the variable separable, we are going to get it as dx over 10 minus x 20 minus x equals 0.01 dt. So before integration we'll do the partial fraction, otherwise we cannot do the integration here. So for partial fraction we are going to take it as 10 minus x into 20 minus x as a times 1 over, that is a over 10 minus x plus b times or b over 20 minus x. Because they are linear, that's why it is going to be like this. And now we will multiply it throughout by the denominator, that is 10 minus x into 20 minus x. So left hand side will get 1, and then right hand side a times, if we'll multiply by this, so 10 minus x got cancelled, so a times 20 minus x plus b times 10 minus x. So it is true for all the values of x, so we can substitute any value. We'll take x value as 10. If we'll put x value as 10, this is gone because 10 minus 10 is 0. So we got 1 equals a into 20 minus 10, that is 10, and hence a is 1 over 10. Similarly, when we can put x equals 20, then we will get it as 1 equals b times 20 minus 20 0. So b into 10 minus 20 is minus 10b, means b value is minus 1 over 10. So we can write this as dx over, I'm going to integrate it directly, so 1 over 10, because it's a, over 10 minus x, minus 1 over 10 dx over 20 minus x equals integration of 0.01 dt. So if we'll integrate from here, it is going to be 1 over 10 times ln 10 minus x, and integration of this is 10 minus x, but we'll divide by the differentiation of 10 minus x, that is minus 1, and again minus 1 over 10 ln 20 minus x over differentiation of this is minus 1, and right hand side it is 0.01 t plus constant of integration c. Now we can rewrite it as minus 1 over 10 ln 10 minus x plus 1 over 10 ln 20 minus x equals 0.01 t plus c. Now we need to get rid of this, get the value of c, and we know that when t equals 0, x equals 0, dx over dt is c. So in these three we can use dx over dt was 2, but we need to use this t0, x is 0. So from here we will get minus 1 over 10 ln 10, because it is 0, plus 1 over 10 ln 20 equals, this is 0, t is 0, so it is gone, so c becomes this, or we can write c value as, since it is 1 over 10, I'll take 1 over 10 common, and it is ln 20 minus ln 20 minus ln 10, that is ln 20 over 10, so it is 1 over 10 ln 2. We have used the property of log x plus log y is log x, log x minus log y as log x upon y. So we got c value, so we'll replace it, and it is minus 1 over 10 ln 10 minus x plus 1 over 10 ln 20 minus x plus 0.01 t plus 1 over 10 ln 2. Let me scroll it up. Now we are going to, it is the solution, but we are going to write x in terms of t. So we can see 10 everywhere. I'll multiply by 10 throughout. So it become minus ln 10 minus x plus ln 20 minus x equals, multiplied by 10, it becomes 0.1 t plus ln 2. So taking all the log terms one side and using the property, we can directly write it as, it is 20 minus x, and it would be minus, so it is 20 minus x, but denominator we are going to get minus 2 and minus 10 minus x, so it is 2 times 10 minus x equals 0.1 t. Now taking writing it as exponent, we can write it as 20 minus x over 20 minus 2x equals e raised to the power 0.1 t. We can always write it because it's a definition, because ln is log base e. And now let's cross multiply. We'll get 20 minus x equals 20 e raised to the power 0.1 t minus 2 e raised to the power 0.1 t times x. I'm collecting x terms one side, and it would be 2 e raised to the power 0.1 t x minus x equals 20 e to the power 0.1 t minus 20, or x can be written as, I'll take 20 common, it is e raised to the power 0.1 t minus 1 over 2 e raised to the power 0.1 t minus 1. I have taken x common from these two as well. So that's the x in terms of t. I hope it is clear. Let's do the last part of this question. And here's the last part of it. State what happens to the value of x when t becomes large. So from the previous part we got x as 20 times e raised to the power 0.1 t minus 1 over 2 e raised to the power 0.1 t minus 1. So when t becomes large, it means t tends to infinity, e raised to the power 0.1 t will also tends to infinity. So what we are going to do, we are going to rewrite it as, I'll take 20 e raised to the power 0.1 t common, so it become 1 minus 1 over e raised to the power e raised to the power 0.1 t, and in denominator also it is going to be e raised to the power 0.1 t common, and we're left with 2 minus 1 over e raised to the power 0.1 t, because in that case 1 over e raised to the power 0.1 t will tends to 0. So these two got cancelled also. So x will tend, or we can say x becomes, because this is gone 0, this is also 0, so we got it as x value as 20 over 2, and it means x becomes 10. So that's it. That was the last question, last part. So I hope it was of some help. Let's meet again in the next video. Till then, thank you so much.